All right, in my previous video, I talked about how to graph the tangent and cotangent parent functions, really just understanding the key components and the five critical points or parts of a tangent and cofunction graph. Now I want to look at a couple of specific examples where we're applying some different transformations. So let's look at this first problem, y equals 2 tangent of x over 4. So the first thing that I always like to do is go ahead and label my axis and start thinking about what do I need to do to figure out my axes. Well, I know that I have a vertical stretch of 2. We wouldn't say that this is an amplitude change. Tangent doesn't really have an amplitude because there's no maximum point, but we would say that there is a vertical stretch of 2. So that's going to help guide me when I'm graphing my axes. So I'm going to label my axis 1 and 2 here. I know I want to include those points. And you could have adjusted your axis accordingly, but I do want to have that. The next part here is understanding that my argument x over 4 can be rewritten as 1/4 x. And that's helpful because I could start thinking about that as a horizontal stretch or shrink. Probably the most important step when you're doing these is to set your argument equal to the places where your vertical asymptote normally would be. So we know from our previous information here that we typically have vertical asymptotes for the parent function tangent of x at negative pi over 2 and pi over 2. So what I'm going to do is I want to see where do those vertical asymptotes move? Where are they now? So I'm going to go ahead and set my argument of x over 4, and I'm going to set it equal to where one of the vertical asymptotes was previously because I want to see where it goes now. So we're going to say x over 4 was, we want to set it equal to, excuse me, to negative pi over 2 because that's where the vertical asymptote was. And just by multiplying both sides by 4, we get x is equal to negative 2 pi. Okay. Now let me do the other one here. So x over 4 is equal to pi over 2. So x then is equal to 2 pi. So let's think about this for a second. We previously had vertical asymptotes at negative pi over 2 and pi over 2. Now look at where those vertical asymptotes are, at negative 2 pi and positive 2 pi. So you can imagine what we've done is we've widened out the area or the distance between these vertical asymptotes. We've stretched them out, right? That's why we have a horizontal stretch here. Okay, and so that has some implications for us in terms of where our asymptotes are, the length of our period. We can say from what we just did up here that our A value, not our amplitude, but our A value is equal to 2. And our period now is going to be 4 pi. We can see that it's the distance between negative 2 pi and 2 pi. You could also just say, all right, my normal period is pi, but if I divide it by my B value here, which is 1/4, I get 4 pi. So it doesn't really matter how you look at it, whether or not you look at it as a distance between negative 2 pi or 2 pi, they're all the same thing. So now we're ready to label our axes. I know I'm going to have my first vertical asymptote at negative 2 pi. And I know that my period divided by 4, so period divided by 4 is going to be pi, or excuse me, 4 pi in this case divided by 4, which is just pi. So I want to make sure that all of my critical points are pi radians apart. So that's going to help me, label my x-axis as such. So what I've done so far is I've labeled all my key points for one full period of pi, okay? And you know what? I know I'm going to have to graph a second cycle in just a second, so I might as well just keep going with this. So 3 pi, 4 pi, 5 pi, and 6 pi, okay? Let's go ahead and start by graphing our vertical asymptotes. And let me make that a little bit larger, okay? So I have my first vertical asymptote at negative 2 pi. And then my second vertical asymptote has now stretched out to positive 2 pi. And since I know a full period is 4 pi radians apart, might as well just graph my other vertical asymptote to complete 2 full periods, okay? So now I can go back here. Let's change my pen settings so I can draw this now. All right, so we know that for tangent, it goes low, mid, high, asymptote. So asymptote, low, mid, high, asymptote. So I've got my asymptote. I can graph my low point here at negative 2, mid, and then my high point up here. Not my highest, it's not my maximum, but a high point there. and I can just graph something that looks something like this. It's not a terrific graph, but it'll work. Okay, now let's graph my other points. I've got my asymptote, low, mid, high, asymptote. So this is going to go something like that. And there's my tangent graph. Zoom out a little bit so you can see that. Okay. All right, let's try this cotangent one now. So a cotangent, I'm going to note that my vertical stretch is 3. So my A value, again, not my amplitude, but my A value is 3. This is written in a way that it might confuse you a little bit, but it might help to just also think of this as pi over 4 times x, if that helps at all. Okay, but just know that this is my argument. So I'm going to take my argument here, and I'm going to set it equal to where my vertical asymptotes were previously. Again, for a cotangent graph, I had vertical asymptotes at 0 and pi. So I'm going to set my argument equal to those places to see where are my asymptotes now. So I'm going to say pi x over 4 and set it equal to 0. Just by multiplying both sides by the reciprocal, I can just say x is equal to 0. So that asymptote hasn't moved. Well, it kind of has. We'll talk a little bit about that. Pi x over 4, my argument, equal to asymptote. X is equal to, in this case, 4 when I multiply both sides by the reciprocal. So my asymptotes were previously at 0 and pi, but what we've done is we've stretched out, but because one of the asymptotes was already at 0, and you're multiplying by a value or dividing, it's going to stay at 0. So you're going to get that stretch motion by actually moving the other asymptote. What is the distance between these 2 points? You can say it's just equal to 4, just looking at the distance between 0 and 4. Again, if you want to go pi over 4, you would get the same thing. All right, so now we're ready to label. I know that I need to have enough space on my y-axis to include my A value of 3, so I'm going to go 3, 0, negative 3 here. I need to make sure that I have my vertical asymptotes at 0, 4, and then the next one would be at 8. So I'm going to go ahead and graph those. Make sure I have get that done first. So let's 0, and I'm just going to plot these first. I know I haven't graphed the x-axis or labeled the x-axis yet, but I know where these are going to be. So just do this first. And, okay, oops. All right, so my first asymptote's at 0, second asymptote's at 4, and then the one to graph another period would be 8. So just fill in the values in between. So this would be a 2, 1, 3, 5, 6, 7, and 8. So what's really nice about this one is that our period doesn't have to be written in terms of pi at all. And that's probably one of the areas where students get the most confused. They think that they have to have pi in there somehow, and they're trying to put these points in between pi, and I'm like, you know what? Your period is just 4, so why not just write everything in terms of that integer 1, right? Don't make your life more complicated. So for cotangent, we know it goes asymptote, high, mid, low. So asymptote, high, mid, low. And there's one full period. Asymptote, high, mid, low. There's another period. And that's it. It's as simple as that. Okay, there should be additional problems for you to work with in the textbook or in WebAssign, but hopefully this gives you a good sense of how to graph tangent and cotangent. Again, one of the biggest pieces of advice I can give is just setting your argument equal to where your asymptotes would normally be to see how they've been transformed.